we learn about the electrochemical series, and on the basis of the electrochemical series we find out that what product will form during the electrolysis when the electrolysis of certain salt is carried out. That means what will be formed at anode and what will be formed at cathode. Now let's talk about the quantitative aspects of this electrolysis. Quantitative means how much substance will deposit. Like if I'm carrying out electrolysis of molten NaCl means where I'm taking only NaCl in a liquid state, then how much Na and how much chlorine, that means how much sodium metal and how much chlorine gas will evolve during the process, I just wanted to know. So here just to know means how much amount of substance will deposit. Just for the for knowing that value, let's talk about first the charge or electricity. So here the first part is let's talk about the electricity. Or we use the word charge for it, and we represent it by capital letter Q. The charge, that is the amount during electrolysis we pass some electricity, and from that electricity some chemical reactions is carried out. So if I'm passing some electricity, then electricity is measured in some quantity. So now let's see. Now here for Q, the Q which is equal to nothing but I into T. It's a formula for Q. I into T, where I is the current and the T is the time. If I is considered in ampere and time is considered in seconds, then Q is considered in coulomb. Means I can say the Q, capital C, becomes the unit for the Q, that is a charge, and it is called coulomb. Okay. Now if I is equal to 1 ampere and time is equal to 1 second, then I can say that on substituting the values, 1 into 1 will give you 1. That means Q will be equal to 1 coulomb. So what is 1 coulomb? 1 coulomb is nothing but the amount of electricity which is produced when a current of 1 ampere is passed for 1 second. When the current of 1 ampere is passed for 1 second, means if during the electrolysis, if I'm passing electricity of passing a current of 1 ampere for 1 second, then the amount of electricity passed through the circuit is nothing but equal to 1 coulomb. Now let's talk about the unit of electricity or unit of Q or charge. So unit of charge, here I can say that we have two units for charge. The first one is a coulomb and the second one is a Faraday. Coulomb, it is represented by capital letter C, and Faraday is represented by capital letter F. Coulomb, I can say, is a smaller unit relative compared to the Faraday, or I can say Faraday is a bigger unit. Now, as I said, what is coulomb? The 1 coulomb is nothing but the amount of electricity passed through the circuit when a current of 1 ampere is passed for 1 second. Now let's see what is 1 Faraday. What is 1 Faraday electricity? Now, to know the 1 Faraday electricity, first, that what is a charge on 1 electron? I know that during the electricity, the electron is transferred, or there is a gain or loss of electron at the anode or cathode. So what is the charge on 1 electron? Then I can say that charge on 1 electron is 1.602 into 10 raised to minus 19 coulomb. Means I can say that if there is a transfer of 1 electron, that means that there is a transfer of 1.602 into 10 raised to minus 19 coulomb electricity. Or for transferring of 1 electron from one electrode to other electrode, I can say that how much energy is needed. Then answer is 1.602 into 10 raised to minus 19 coulomb. This is the charge on 1 electron. Now let's see what is the charge on 1 mole electron. If I am saying 1 mole electron, that means there is a 6.022 into 10 raised to 23 electrons, and each electrons will have 1.602 into 10 raised to minus 9 coulomb electricity. That means this is equivalent to 96,478 coulombs, which can be approximately taken as 96,500 coulombs. That means I can say this is the amount of electricity which is passed when the 1 mole of electron is transferred from one electrode to other electrode, or when there is a gain or loss of 1 mole of electron. So here I can say that a very important statement, that charge on 1 mole electron, a very important statement, that charge on 1 mole electron is equal to 96,500 coulombs. So this is a very important relation between the Faraday and this is the charge on 1 mole electron, that is 96,500 coulomb, which is represented by 1 Faraday. Means I can say the 1 Faraday is nothing but the 96,500 coulombs electricity, which is equivalent to charge on 1 mole electron. Means if the question is that how much electricity is required for the transferring of 1 mole of electron, then simply answer I can say that 1 Faraday. Or if I am passing 5 Faraday of electricity, it means during the electrolysis the 5 moles of electron has been gained or lost at a respective electrode. So the number of moles of electron deposit gain or lost is always equal to the number of Faraday of electricity which is passed through the cell. Now, as I said, we are talking about the quantitative analysis or the quantitative part of the chapter. That means here, if the electrolysis is taking place, then at anode and cathode, some substances will deposit. Then quantitative part, that means how much, I just wanted to know that how much substance is getting deposited. So, for example, suppose if I am doing an NaCl, if the electrolysis of NaCl is carried out, then during electrolysis, the how much Na or how much Cl will deposit, I just wanted to know. Then the answer that how much Na and how much chlorine will deposit, the answer we get from the Faraday's law. So we are having the two laws of electrolysis, which are known as Faraday's first law of electrolysis and the Faraday's second law of electrolysis. Now let's start with the Faraday's first law of electrolysis. So Faraday's first law of electrolysis. What law is? The law states that the amount of a substance deposited at any electrode is directly proportional to amount of electricity passed through it. Passed through cell. So Faraday's first law of electrolysis, according to which the amount of substance deposited at any electrode, that means either at anode or cathode, is directly proportional to the amount of electricity which is passed through it. So if the amount of substance, let I am representing it by W, that is a mass of substance, let's consider, is directly proportional to the Q, where Q stands for the amount of electricity, that is, or I can say the charge which is passed through the container. Now let us try to understand the meaning of this statement, why it is said like that amount of substance deposited is directly proportional to the amount of electricity. So suppose if I am carrying out the electrolysis of NaCl, I have taken a molten NaCl here, two electrodes are there, one will be a cathode and one will be anode. Positive electrodes are generally anode, and in case of electrolytic cell, the negative electrodes are generally cathode. So let this is anode and cathode, and here we have molten NaCl inside, and molten NaCl, that means we have a large number of Na plus and NCl minus. There is an infinite number of Na plus and Cl minus ions. Now during electrolysis, what will happen? The sodium will start migrating toward the cathode. There is a negative electrode and sodium will deposit here. Being a cathode, the reduction will take place. The reduction will take place means I can say that the sodium will gain electron. So sodium takes electron and produces sodium metal and get deposited on the electrode and on the surface of the liquid, as it is a lighter than molten NaCl. Okay. Now here I said that how much amount of sodium will deposit, it totally depends upon the Faraday's law says that how much sodium will deposit, it totally depends upon that how much electricity is passed through it. So currently from the diagram, from the reaction, I can say that how much sodium is depositing, it depends upon that how much electron is passed. Because if I am passing 1 mole electron, then the amount of sodium deposited is also equal to 1 mole. That means I can say 1 mole sodium means 23 grams sodium, as the 23 is the atomic mass for the sodium. So if I am passing a 1 mole of electron, that means 1 mole of sodium is deposited. That means 23 grams of sodium is deposited. If I am passing 2 moles of sodium, so for, suppose if 2 moles of sodium is deposited, then for deposition of 2 moles of sodium, I can say that 2 moles of electrons are required. So if I am passing 2 moles of electron, if there is a 2 moles of electron, then 2 moles of sodium will deposit. 2 moles of sodium, that is a 46 grams of sodium. Now, so here I can say that the number of moles of sodium deposited, or the amount of sodium is depositing, it directly or it depends upon how much electrons are passed. If the 5 moles of electrons are passed, then I can say that 5 moles of sodium will deposit. So here currently I can say that amount is directly proportional to the number of moles of electron. That how much electron is passed. Now here, now how much electron will pass, the number of moles of electron passed, how much electron will pass, it depends on the amount of electricity. How it depends on amount of electricity, then simply I will say that if you are passing 1 mole electron, suppose if you are passing if 1 mole of electron is transferred, or if 1 mole of electron is produced, then for production of 1 mole of electron, it requires some amount of electricity. How much? 96,500 coulomb. That means I can say that 1 Faraday electricity will require. So similarly, if 1 mole of electron is passed, that means the overall 1 Faraday electricity is passed. That's why the 1 mole of sodium is deposited. For passing a 2 moles of electron, again the electrons will not deposit by its own until and unless the electricity is supplied or that battery is on. Once I switch on the battery, the electricity will pass through the circuit, and then only the electrons will transfer. That means it will be gained or lost. So that gain or loss of electron totally depends, will takes place only when I'm passing electricity, and how much electron will be gained or lost, it totally depends upon that how much amount of electricity has been passed. If I'm passing 1 Faraday electricity, that electron deposited is 1 mole. So here I can say that if 1 Faraday electricity is passed, then electron deposited is 1 mole electron, and 1 mole electron will form 1 mole sodium. If I am passing 5 Faraday or 2 Faraday of electricity, then 2 Faraday of electricity will accelerate 2 moles of electron, and these 2 moles, after gaining 2 moles of electron, I can say 2 moles of sodium will form. If I am passing 5 Faraday of electricity, 5 Faraday means 5 into 96,500 coulombs of electricity, then simply I will say that 5 moles of electron has been accelerated, which will be gained by the 5 moles of Na plus, and that's why the 5 moles of sodium will form. So simply I can say that how much sodium will form, it depends upon that how much electricity is passed through it. Then let us talk this in a similar manner. I can say for the chlorine ion also, if the chlorine minus, Cl minus, it will move to the anode, and when it will move to anode, on anode the oxidation takes place, that means the electron is lost. But we know that the chlorine always form, or it will deposit in the form of Cl2, so 2Cl minus will lose 2 electrons and will form Cl2. So here in short I can say that if the 1 mole of chlorine is formed when the 2 moles of electrons are lost, If it is a cathode, then electrons are gained, and if it is anode, then electrons are lost. That means I can say that for the production of 1 mole of chlorine, how much electrons are lost, how many moles of electrons are lost, then answer is simply that 2 moles. So here I can say that for passing a 2 moles of electron, simply the 2 Faraday of electricity is needed, or I can say if 2 Faraday of electricity is passed, then ultimately 2 moles of electrons will get accelerated, and due to which I can say that 1 mole of chlorine will deposit. Or if 4 Faraday of electricity is passed, then means 4 Faraday, then I can say that 4 moles of electrons and 4 moles of electron, that means here I can say 2 moles of chlorine. If 1 moles of chlorine, that means here I can say 1 mole chlorine. Chlorine molecular mass is 71, that means the total 71 grams of chlorine is formed. Either you say 71 grams of chlorine is formed, or I can say that 22.4 dm cube of chlorine has been produced, because 1 mole of chlorine is nothing but equal to 22.4 dm cube. Or I can also say that, or it can be, or I can write that 6.022 into 10 raised to 23 chlorine molecules has been formed. That means if you are passing a 2 moles of or 2 Faraday of electricity, then how many molecules of chlorine has been deposited? Then answer is 6.022. Or how many dm cube of chlorine has been produced? Then answer is 22.4 dm cube. Or how much gram? Then I will say that it's a 71 gram. Similarly, if I am passing 4 Faraday of electricity, then 2 moles of chlorine, that means I can say 142 grams of chlorine. Or can be said that 2 into 22.4 dm cube of chlorine will deposited. That means 44.8 dm cube, or I can say that it is equivalent to 2 into 6.022, that means 12.044 into 10 raised to 23 chlorine molecules. So here, how much chlorine will deposit? If you want still more number of chlorines, then simply I will say that pass more amount of electricity. If you are passing 6 Faraday or 5 Faraday of electricity, then 5 moles of electron will transfer, and so that 2.5 moles of chlorine will deposit. So how for the deposition of 1 mole of substance, how much electricity is deposited, we can calculate, or we can conclude it from the reaction, right? Reaction, balance reaction. From the balance reaction, we can predict that for the deposition of 1 mole of a substance, how much electricity is required, which is predicted with the help of this electron. So in short, I can say that the amount of substance deposited is directly proportional to the amount of electricity which is passed through the cell. So this is the Faraday's first law of electrolysis.